Okay guys, today we are doing Gaussian elimination, and it's basically what we did last time, but without the variables. Sometimes when we have the variables x, y, and z, it can become a little bit cluttered, and then there's just too much to look at. So to be more efficient, you're going to see what we're going to do with these matrices and just the coefficients of said variables. Okay, so first of all, perform operations on rows until the matrix is in reduced row echelon form, RREF, or even just row echelon form. That's just REF. So operations include the following. Okay. First of all, you will multiply, so there's multiplication involved. There is also addition and subtraction. And then finally, what looks and appears as you're swapping rows. Okay? Alright, so you just have to see it, and it does take a little bit of time to see it, maybe 2 or 3 examples, and then you can start seeing the pattern. Okay, so let me highlight for you our goal. Our goal is to start right here. Okay? At that 1, that upper left-hand corner number is where we start. Where we end will be right here. Not the last column, but the one just before. So this is the last column. The one just before that, the very bottom right-hand corner. And you see that you're creating this diagonal of 1s. Okay? Now, the way we progress through this, guys, is the following. Okay? We're going to start here, go down, then go right, then go up, then go right, and then go down, and we will finish at 1. So it almost looks like a zigzag pattern, for sure. Okay? But that's, that's our roadmap. In row echelon form, where you could still have like x plus y plus z is equal to some kind of number over here. If you were to kind of envision this of what we did last class, there's the equal sign, to where all of those to the right are the numbers that they're equal to, and everything to the left are the variables that they're equal to. Okay? So row echelon form still starts at the same place. The only difference is it stops here, ensuring that 1 is my coefficient. So you could say it does something like that. So you still go down, right, up, making that 1, and then finally you make that 1, and then you can be done. Okay? Okay, so what this is, it's called an augmented matrix. And the augmented matrix, this one has 2 variables and then numbers over here. To where what you were used to looking at this as last class would have been 3x plus 4 is equal to 1. And negative 3x plus 2 is equal to 23. This is what you were used to looking at it as last class. Okay? The only difference is that, oops, I forgot the y. 4y and 2y. So 3x plus 4y equals 1. Negative 3x plus 2y is equal to 23. Again, imagine that on this line is where that boundary is, where the equals line up. Okay? First of all, when you write these out, all x's must be in the same column, all y's must be in the same column, and all z's must be in the same column for you to be able to do this progression throughout. Okay? Now, if we were to do substitution, just a little bit of practice, not substitution, I'm sorry, elimination, wouldn't I add these to cancel x? Okay, how many y's do I have? 6y. 6y is equal to what? 24. So y is 4. And if y is 4, we have 3x plus 16 is equal to 1. So 3x is equal to a negative 15, and x is equal to a negative 5. So negative 5, 4 is my answer. Now that was just so you can see where it is that we're actually going to go in this whole thing of row reduced echelon form. Okay. So at least you know now what our answer is going to be. Alright, so let's go ahead and work to it. The first thing that we're going to do is we're going to start at the upper left-hand corner. You with me? Now, we want to make 3 into what number? Not 6, 1. From what we're learning today, we want to make this eventually look like this. So we want these 4 numbers to end up looking like this, because when we get it there, then these right here will be our answers. Since x is listed first, here's x, here's y. On my answers, x and y would be listed like this. If there was another z, it would be x, y, z. Okay, so left to right up here, top to bottom over here. So you know how to read your answers. So ultimately, our goal is to find x equaling a negative 5 and y equaling a 4. Our goal is to create this matrix. Okay? So, you notice that there's zeros everywhere surrounding, bless you, surrounding that diagonal of 1s, right? Okay. So now, we're starting here and we need to make a 3 into a 1. How do I do that? I could just divide by 3. Now here's where we did it last class. Let's call all of this right here, we're going to call it row 1. And we're going to call all of this right here, we're going to call it row 2. Okay? Here we go. I'm about to make this 3 into a 1, because I need to, and I'm going to do that by saying 1/3 times row 1. Okay, you with me? So when I do 1/3 times row 1, what is it that it's going to, what is all this matrix going to become? What changes? Row 1 changes. So row 1 is now going to become what? It'll be 1, 4/3, and 1. Or sorry, 1/3. Everything else stayed the same. Okay? So this is still here like that. And you could say that this never changed. So what's in red was the change that happened from the previous matrix to this next step matrix. Are we good? Okay. So now, we just did this and satisfied to get 1. Now let's take the road map. Remember how I said the road map would be? It's going to be like that. Okay? So our goal now is to change this -3 into what number? 0. Okay, so think about this. I'm going to use multiplication, addition, subtraction, and swapping. So you got to be very creative with this. My best rule that I can tell you right now is that when you're trying to make something into a 1, you're going to multiply or divide. So multiply or divide. If you're trying to make something into a 0, you're going to do what? Add or subtract. Now, remember I've talked about this a lot. Multiplication and division cancel to a form of 1. Addition and subtraction cancel to a form of 0. You with me? Okay. So here's what we're going to do. This first one, let me get a little bit more organized with my work because I want you to be this organized. 1/3 of row 1 ended up to this. And now what we're going to do is we're going to change something else. Okay? We're going to say, here we go. Actually, let me ask you, what could I do to make this, -3 into a 0? Okay, so here's how we're going to do it. Now pay careful of what I'm doing. You're right. I have to add 3. But I have to find a row to grab that from. Okay? Here we go. I'm going to do 3 times my new row 1. This is my new row 1. And I'm going to do 3 times that. You with me? So if I do 3 times that, it would be what? 3, 4, and 1. Do you agree? Okay? So I'm going to do scratch work just off to the side. 3 times row 1 would give me 3, 4, and 1. And what I'm going to do is I'm going to add it to row 2. You see what I'm doing? Adding it to row 2 is -3, 2, and 23. How's that? So my new, this -3 is going, because of this, right here, this -3 is about to become what? 0, which is what I need it to be. If you're struggling, you got to ask me now because this is just a 2x3 matrix. We'll do 3x4, okay? Yes?
Why do you have to do that?
Okay, my goal is to get these zeros surrounding this diagonal of 1.
But wouldn't that eliminate? The one's not there.
Okay, so let's keep going with this, okay? So when I do this, what will the 4 plus 2 equal? 6. And what will the 23 plus 1 equal? 24. So what we're going to do right now is we're going to show that this operation ended up making the second row per se 0, 6, 24. Everything else stayed the same. 1, 4/3, and 1/3. Okay? This scratch work that I did over here, I don't want you to write that down in your work, like on a quiz or a test. I want you to do it. You can do it off to the side, but what I'm only writing over here is what I want you to write down. Okay? So this is our row 2, this is our new row 1, and this is our new row 2. Now, the thing is I don't want you to basically do this. You don't have to write these row 1s and row 2s. You could just write it just like this as I'm doing it right now. Yes?
When we multiplied row 1 by 3, that only applied to row 2.
So listen, when you multiplied, let me highlight it as we go. When I multiplied row 1 by 3, I got this. Okay? So all of this right here is this. You with me?
Yes.
And if I add it to the current row 2, you with me?
Yes.
Which is all of this right here, I would end up getting this new row 2 per se. That's a big, okay. You see what I'm saying? So I added it to get me a cancellation form of 0. And now I'm ready to continue going forward. Let me unhighlight these so that you can see it a little bit clearer. Okay. So far so good. Okay. What's the next number that you see in our current matrix, our current running answer? What's the next number that I need to change? A 6. And I'm going to change it into a what? A 1. So here we go. Remember what I said from before. If if you want to make things into 1, most likely you're just going to multiply or divide. So what am I going to multiply? Which row am I going to multiply? Row 2, the bottom one. So I'm going to take row 2, and I'm going to multiply it by 1/6 or divide by 6. Same thing. You with me? So I like to put multiplication. And those of you who don't like fractions, you gotta jump. You gotta come to the light. Okay? 1/6 of row 2. This change to the matrix made this become 0 what? 1, 4. Everything else, as you keep seeing me do in black, it's just staying the same. Nothing happened to everything else. And right now, if you had a question that says, using reduced echelon form, solve for x and y, guys, you would be done right here. Because reduced, it wants the diagonal and everything to the left to be zeros. Okay? So that means if I asked you this specifically on a quiz, you would say, ooh, x is equal to 1/3, y is equal to 4. This would be my answer, and I would be done. But most likely, you're going to be asked to do row reduced echelon form. So we got to keep going. Okay? We have one more thing to do. One more number to change. And what's that number in our current matrix that we need to change? 4/3. All right, here we go. We're trying to make 4/3 into what number? 0. Okay. Can I multiply the same row by something to make this 0? Yeah, I could. I could multiply it by what? 0. But then what does that do to this? Then you mess everything up. So when you cancel to a form of 0, you're not going to work with your equation per se. That row, you're not going to work with this one to make 4/3 0. You're going to work with a different row to make that 4/3 become 0. You with me? In this case, we're going to say, here we go. We're going to say a negative 4/3 times row 2. Go with me? Which is going to be scratch work off to the side. Negative 4/3 times 0. So here we go. Negative 4/3 times 0 keeps the 0. Negative 4/3 times 1 is a negative 4/3. Are you with me? And then what's the last one going to be? Negative 16/3. This right here is row 2 times negative 4/3. And what I'm going to do is I'm going to add it with what? Row 1. Because row 1, which didn't change, is this. You with me? So if I add these together, what am I going to get as an answer? 1, 0, and negative 15/3, which is the same as what number? Negative 5. So this became my new row 2. Okay, here we go. Let me show the change. We just changed our row 1 to become this. Our row 2 stayed the same. And right here, guys, whoops, there you go. X is negative 5 and Y is 4. And we know we can stop right here because my diagonals of 1 with my surrounding zeros have been completed. And now I know that that is my final answer. Yes?
When you're writing the thing R2 plus R1, so the only thing we change is the first one that comes up? The first row?
The first row, yes. Yes?
Will it always
It will always be, it will always try to get those ones and zeros, yes. And when you finally, it's called the identity matrix. And when you finally get it down to the identity matrix per se, as far as the diagonals of 1 and the zeros around, that last column as it sits is your answer. That program that we have, menu 371, right? That's what it's doing in a blink of an eye. It's doing all these steps like that through a program function. Okay? I didn't learn this till I was a freshman or a sophomore in college. Just by the way. We learned it to a different level, but it's still, it's a little intimidating when you first see it, okay? Let's do some more example problems for sure. Guys, you got to focus big time on your questions. If you focus on the deeper question after this, will get easier, okay? All right, here we go. Yeah, ours were like 4x5, 5x6, 6x7 matrices, and it was a nightmare to do those. Those were huge matrices, okay? Many variables, not just 3. You'll have at 3 the most. Okay, here we go. Oh, remember, step 1 is establish the roadmap. Establish your roadmap. What direction do I need to go to progress through this now 3x4 augmented matrix? So this is a 3x4, 3 rows by 4 columns, which we used to call it as 3x3 of 3 equations and 3 variables. With augmented matrices, you're accounting for that last column, which is just constants, just numbers. Okay? So again, we're not going to solve this out, but what I want you to do with your calculator to get extra practice is I want you to envision this right here as x plus 2y minus 3z is equal to 7. X plus positive 1y minus 4z is equal to a negative 6. And then 0x, so I don't need an x, 2y plus a positive 1z is equal to 3. This right here is that matrix that we can use, that menu 3 for algebra, 7 to solve the systems of equations, and then it's just 1. Menu 3, 7, 1. Now,
My calculator's not doing
I didn't hear you.
My calculator's not showing up.
So guys, if your calculator never turns on, look, do this. There's a button on the back. It says reset. Just press and hold it for 2 seconds. And they kind of mess with the buttons and it will reset, okay? Alright, here we go.
Awesome. Never mind.
If we do menu 371, does anyone have those answers? Go ahead, Corbin.
X equals 96.
96?
Yeah. Y equals -10. And Z equals
23? Okay, so x is equal to 96. You can write it like this. Y is equal to negative 10. And z is equal to 23. And this is the answer as a point per se. And this is as a list. Our goal is to get our original matrix to look like this. 1, 1, 1, zeros all around. And then the last column should show 96, negative 10, 23 in this exact order, because our x, y, and z were established like this. So our x, y, and z answers will go x is equal to this, y is equal to this, and z is equal to this. That's our goal. Questions? All right, here we go. So now that we know our answer, let's go and work the problem the new way. 3x4 augmented matrix with row reduced echelon form. Here we go. Is this good the way it is right now? So there's no change. That doesn't have to change. So our first change is actually going to occur right here. And what are we trying to make that number? 0. So if I'm trying to make this 0, could I just multiply all of row 2 by 0? No, that's not what I want to do. Okay? If you want to cancel to a form of 0, you're going to have to borrow a different equation, which you'll end up adding to row 2. So some other row has to add with row 2 to make this 1 into a 0, the one that I have highlighted in green. So let's say, which row could I do? Row 1. And I'm going to multiply row 1 by a negative 1. So look, a negative row 1, I'm going to do scratch work off to the side, would give me a negative 1, negative 2, positive 3, negative 7. This is scratch work off to the side that I don't want you to include in your answer, but you can do it off to the side to help you think. So negative row 1 gave me that. What am I going to add to this? Row 2. And my goal, when I do this right here, will end up making this 1 into a what? A 0. Okay, here we go. So let's see it actually happen. So row 2, as it sits, is 1, 1, negative 4, negative 6. When I add them, there's the 0 that I wanted this to become. And I have what left over? Negative 1, negative 1, and negative 13. Okay, so just now, my original row 1, row 2, row 3 just became the following. 1, 2, negative 3, 7. Okay? That, although we used it, it didn't change. We used it to change row 2. And what does row 2 now get written as? 0, negative 1, negative 1, negative 13. Everything else stayed the same. And we're on our way. Yes?
Would it matter if you did negative row 1 plus R2, or would you do row 1 minus R2?
That's, okay, so listen. A negative row 1 plus row 2, let's say that's like negative, I'm going to make up some numbers. 10 plus 5. What would you get? Negative 5. And Michael asked a very, very good question. What if you did row 1 plus a negative row 2? You see what I'm saying? What if you did a positive 10 plus a negative 5? It would be different. So you have to be careful of which one you're applying this negative to in order to add it through. Are you with me? That was a very, very good question. All right. So let's keep going. All right, so let's check our roadmap's progress. Is that good? Yep. Good? Yep. Good? Okay, so we can skip that one. We don't even have to work with that one. What's the next number we're going to work with? The 2. And our goal is to make it into a what? No. A 0. You're right. It is a 0. Because ultimately, we want the diagonals of 1, because this is a 3 by 4. All right, so let's make this 2 into a 0. So already you know, what are we doing? Adding or subtracting something. And we're going to add a different equation to row 3. Okay? Here we go. So you know, to get this 2 to a 0, you're going to end up adding row 3 to some equation manipulation. Which one is it, guys? So here we go. Negative row 1, people said. And say again. A 2 row 2, people said. You with me? You have two choices that you could do right here to add to row 3 that'll make that into a 0. And only one of them is correct. Who can tell me which one is it? If I add a negative row 1, first of all, that's a big O. You have to see that one. That one's a big O. Because look at row 3. Row 3 is this right now. And if I add a negative row 1, okay, versus row 3 again, what if I add a 2, row 2? So when I add these two together, this is a big O moment. Over here I'm going to get negative 1, 0 that I wanted, 4 and negative 4. Here I'm going to get 0, 0, a negative 1, and a negative 23. They both accomplished what I was trying to get them to do, but only one of them is right. Which one is it?
The left one.
The left one right here, when I multiplied by 2. Because I need this 0 to stay a 0. I cannot change it and undo what I just did the step before. Okay? So you'll see as you progress, you want to borrow the ones that have these zeros already in there to make the other ones become 0. Otherwise, you're going to add back on. And you just undid your progress. Okay? All right. So, let's get to it. We're going to do 2R2, negative 1, negative 23, just so that I don't have to do that again. Negative 1, negative 23. So 2 times R2 plus R3 gave me 0, 0, negative 1, and negative 23. Everything else in this matrix stayed the same. And guys, the color coordinating helps so much the way I'm doing this, because whenever I learned it, it was just pencil or marker and whiteboard. Are we good? All right, here we go. Good, 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 good. But I need to make this now into a what? Positive 1. When I make things into, what am I going to do? Am I going to multiply, subtract, add, or divide? I'm going to multiply. What row? Row 2. By what? Negative 1. So negative row 2 is now going to build me the following. So this negative row 2 change became 0, 1, 1, 13, and everything else stayed the same. How are we doing? Still good? Okay, here we go. Good, 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 good. Now I got to make this 2 into a what? 0. So remember, making this 2 into a 0, let me hear some suggestions out there. So, negative row 2.
Negative 2 row 2.
Okay, so negative 2 row 2 is going to be added to what? Row 1. Are there any other suggestions out there? I think this is it. Because negative 2 times row 2, just scratch work off to the side, is going to be 0, negative 2, negative 2, negative 26. That's negative row 2. This is my scratch work off to the side. And I'm adding this with 1, 2, negative 3, 7. What does it become?
1,
It becomes 1, 0, negative 5, negative 19. That's what our first row is about to happen. Notice, the 1 stayed the same. It's right here. It stayed the same. It didn't change. And we still were able to accomplish that to become 0. So over here, off to the scratch work, or the real work, I'm going to write is negative 2R2 plus R1. Just like Tyson said, becomes 1, 0, negative 5, negative 19, and everything else stayed the same. Questions? Okay, so let's go back. Let's get rid of the scratch work. And again, I would say the scratch work you could do writing on the desks is probably my best suggestion. Let's go through it and see what progress we've made. Good, 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 good. The next number we have to do is negative 5. These are as long as they get, by the way. 3 by 4s are as long as they get. Okay? But this will be on the non-calculated portion of your test. So, our goal is to make this negative 5 into what number? 0. Okay, I'm going to add some other manipulation of other equations. What row do you think I'm going to add to row 1? Row 2? Row 3. Because if I add row 2, look at this. It will possibly make that 0 go back to some other number. We want to keep it 0. You with me? And the way we keep it 0 is to add it with one of the equations where that column is already 0. Okay? So, what am I going to do? What times row 3? Negative 5. Nice. Negative 5 times row 3. If you have to do the scratch work off to the side, quickly do it. That's going to be this. So negative 5, 15, 10, 1. So that's negative 5 row 3. Okay? And we're going to add it to what? Row 1. Row 1 is 1, 0, negative 5, negative 19. This is why I love the scratch work, but again, off to the side. Because I can see right now, the 1 stayed as 1, the way I want it to. The 0 stayed as 0, the way I want it to. This third column became 0, right? The way I wanted it to. And what's that last number? 96. So we're going to say the row 1 now became 1, 0, 0, 9, 6. And we're almost there, guys. So 0, 1, 1, 13. This is why last class was so important with that practice. We just need to change 2 more things. This 1 and this negative 1. That's it. Okay? So let's do it in the progression that we're supposed to. Okay. I want to make this 1 way down here into what number? 0. What's the equation that I'm going to be working with? What am I going to write? What equation would I write? Yep, row 3 is going to be added to what? Row 2. Scratch work. Row 3 is added to row 2. The 0 stayed the same, which I wanted it to. The 1 stayed the same, which I wanted to. And bam, this became 0. And this is negative 10. So my second new row is 0, 1, 0, negative 10. Everything else stayed the same. And we are almost there. One more manipulation. Which one is it? Row 3 is going to be what? So a negative row 3 will make this last column or row become 0, 0, positive 1, positive 23. Everything else stayed the same. And now, because this was X, Y, and Z, what's our X? 96. What's our Y? Negative 10. And what's our Z? 23. Is that what we got with the calculator? There you go. Okay, so real quick, I'm going to show you how to check with your calculator two different ways. Because I want you to do practice problems, and I want you to get good at two things at one time. Practice without a calculator algebraically for sure, but making sure you can do it by a calculator to get your answer so you know what you're supposed to get. Alright, so here we go. Let me go ahead and quickly sign in.
You never touch.
Don't worry about that today. Alright, so with the calculator, let me come over here. We are going to, first of all, do it just real quick for video and instructional purposes. We're going to do it the old way. Okay? So 1, 2, negative 3, 7. 1, 1, negative 4, negative 6. 0, 2, 1, and 3. The way we're going to do this, just for people who are absent, menu 3, 7, 1. Delete and make it 3 and press enter.
Wait, what about? Oh, it automatically adds the line.
Yep. So now we're going to do x plus 2y minus 3z is equal to 7. Then x plus y minus 4z is equal to negative 6. I'm just copying down my matrix. And then 0x, so I don't need that. 2y plus z is equal to 3. We've got to be very careful that we put negatives and positives where they occur. And you see that we got x is 96, y is negative 10, and z is 23. Okay? The other way to check it is like this. Here we go. I'm going to do row reduced echelon form. RREF. Parentheses. And now I'm going to go and look for this matrix. Okay, here we go. This button right here has access to a lot of things. It's the button to the right of number 9. Okay? You'll use this a lot for the rest of your high school math career for sure. This 3 by 3 matrix is what you want to choose. Because now it gives you this table that you can alter it. Guys, how many rows do I have? 3. How many columns did I have? I have 4 because this is an augmented matrix. So press 4 and then press enter.
Wait, go back.
Okay, just calm down. Alright, press that button again. Follow me. If not, please, you can watch the video at a later time too because I don't want to slow the progression of the video. A 3 by 3, you're going to press enter. Press the down arrow key. Press delete, which is right here next to this book. And we're going to type in a 4 for 4 columns. And then press enter. Okay? Now, we're going to enter our matrix exactly the way it was given to us on our paper. 1, right arrow. 2, right arrow, negative 3. And then just fill it in. You could go wherever you want. Just put the numbers that were on our original example. And look, it does everything that we just did by hand, like that. Notice the first number is 96, that's x. The second one is y is negative 10, and last but not least, z is 23. Okay, guys, you need to press RREF. No worries. RREF, because if you just put a matrix in, you're not necessarily telling it what to do with it yet. So, at the very bottom of your screen, there's a big old keyboard. Just type out RREF. Okay, RREF and press parentheses. Questions? All right. So now let's go back. All right, guys, so example 4 and example 3 we're going to do in groups in just a bit without a calculator. So we're going to grade the work. But example 4, you tell me, how do I build this matrix? What would I write for the first row? Negative 4, 0, negative 6, negative 12. All you do is line them up. So you get negative 6, negative 4, negative 2, and 6. Because this is the x column, I'll put a negative 1. This is the y column, I'll put a positive 2. This is the z column, I'll put a positive 1. And if there's not 1 there, just put 0 like you've been doing. And 9 would be that last one. Again, remember, there's like an imaginary line right here, if you will. And that separates your equals. Off to the side, what if I had 2x minus 3 is equal to 4y, and then I had 4y minus 8x is equal to 0. How would I do this one, guys, as a 2 by 3? Just no z's. How would I build this matrix? 2, negative 4. Okay? And what? A positive 3. Because we have to change this to match up so that it's 2x minus 4y is equal to 3. We've got to do algebra 1 real quick and put it in standard form where the x and y's are on the left side of this equal sign and the number is on the right. What would I put for my last one? Negative 8, 4, and 0. Ready for practice? All right, here we go.